Hey, everybody, and welcome back to the podcast. I'm excited to introduce you today to Justin Schultz from Page in Washington, D.C. Justin, welcome.
Thank you. Thanks for having me.
Yeah, you bet. Taking time out of your vacation for this, so super appreciate that. Tell us a little bit about Page and your work there in Washington, D.C.
Yeah, so Page is an architectural engineering firm. We're about 1,500 people all across the United States. We focus on all forms of architectural engineering across any building sector you could think of in the United States, which means that we're quite lucky to work with a lot of clients that are owners of their building. They really care a lot about their building. And so I'm part of our building sciences group and I lead our building performance team. So my name is Justin Schultz. I'm the building performance director at Page, and we conduct a lot of building performance analyses, look at energy performance, well-being characteristics like daylight and glare, as well as financial performance like life cycle cost analysis for any of our projects that we're working on to really try and make sure that our clients are making smart decisions today that work for them for the next 30 years.
Giddy up. So not first cost, but total cost. I love that.
Yeah.
We met at the App State Energy Summit at
Yes.
Appalachian State University, where you sat in on the panel with Mike Cap talking about high performance campus design. And you got my tail wagging as I was sitting in the back of the room with Rob Howard and Adam Cohen, who are both building scientists that know way more than I do. But we were talking about passive design, specifically on a project you're working on at Catawba College. Can you share a little bit about that project?
Yeah, so this is a 112 bed new res hall for Catawba College. It is being Passive House certified, Passive House Institute United States certified, which is important because little did we know, it is the first residence hall to receive and go through the rigor of Passive House certification in North Carolina, which is a pretty big deal. Now, of course, there's a lot of single family homes out there, but there's new challenges that you face at a scale of 112 beds in one building. At the same time, it's meeting the campus aesthetic of collegiate Gothic. It's got amenity space for students to not only study within the environment, but hold events as well as other types of kind of communities for the students to really engage with their peers.
Yeah, so let's break down this FIAS certification a little bit and talk about why the enclosure is so important. Before we get to the aesthetics, even before we really talk about the general use, why is it so important for us to start with the performance of a building around how the enclosure performs?
Yeah, so the enclosure plays a really significant role in the environment of the building and the thermal comfort of the building occupants, right? So if we want to think about what is the building enclosure doing or the building envelope doing for our building, it's trying to create a barrier between the exterior and the interior. We as humans have gotten pretty comfortable in our 70 to 75 degree Fahrenheit temperature conditions, but yet we know the outside environment fluctuates very drastically from that. So the building envelope really plays a significant role in keeping people thermally comfortable and protected from extreme weather events. And so when you create a high performing building envelope, you're significantly improving thermal comfort and offsetting the energy that you would need to otherwise create those thermally comfortable conditions for the building occupants.
Yeah, so I come from the commercial world. We were part of a couple million square feet of design, development, and delivery of office product. And, we always talked about the operational efficiencies of a building. And what was interesting about those buildings is that the thermal load, they were generally steel, concrete, glass structures, but yet we would try to talk about the operational efficiencies. So let's talk about that for a second. Is it safe to say if we build a better enclosure system, we could potentially cut back on the long-term costs of operational expenses?
Absolutely. There's a few key ways, right? Obviously, operational expenses, that's the low hanging fruit. Everyone thinks about it that way. Well, if I improve my building envelope, I'm now using less energy to condition my building. And in particular, on the Catawba College Residence Hall, we're using less than 10% of all the energy that the building uses to heat and cool the building, which is incredible. Heating and cooling is the primary energy source in every building across the country. So for us to be using less than 10% for both heating and cooling combined, means that all the other energy is just internal loads and lights and fans for ventilation and hot water. So that's really incredible in of itself. But yes, there's the operational savings. What are we saving on our utility bill? But if you're designing from the very beginning of the project to be passive house, you're also saying, what are my first cost savings? Because you're now able to put in smaller mechanical equipment, smaller systems to push air around your building more efficiently. So you're able to save in other areas. So, yes, the envelope might be a little bit more costly. You're putting more materials there. You need more insulation. But at the same point, you're then saving on your mechanical system sizing because you need significantly smaller systems. Our loads are reduced by over 75% in this building. In other words, we put systems in there 75% smaller than if we just designed it to energy code baselines.
Yeah, it's amazing, how interconnected things are, like hardiness zones, right? What hardiness zone is Catawba College even in? Is it a 6B maybe, as a guess?
Climate zone they're in, or for ASHRAE, they're in 4A.
Okay. Yeah, so they're related. Food. I also do food system resilience, so I always look at hardiness zones at the same.
Mm,
So I'm not the mechanical ASHRAE guy as much as I am the dirt and soil guy.
sure.
But they're totally connected because what grows in one place tends to grow in the other. It's really interesting. And, it was interesting during that same conference, Joe Listerbrook, who was our keynote, I think you're probably part of that. Um, he was talking about how we approach insulation as humans. When we're cold, we put a sweater on. And then if we're cold to prevent getting wet, on top of that, we might put a shell on. So if it's raining
Hmm.
and we're cold, we put a shell and a sweater on. I love that analogy. Can you help me with that a little bit? Expand on that for building scientists, for people who may not be versed in building science a little bit?
Yeah. So that shell, the insulation, we'll start there, is that sweater, and it needs to be continuous, right? When we put on a sweater, if we have a zipper sweater, right, zipping it all the way up is going to keep us a lot warmer than when we unzip it. And a lot of times we're designing buildings where we're not accounting for that sweater not having holes in it, right? Big holes in that sweater is going to make us feel a lot less comfortable. And so that result can apply to our buildings too. We call those thermal bridges, where we get a lot more heat transfer through those holes in the insulation. And what's so important about FIAS is the rigor that goes into a thermally broken free building enclosure. And if there are thermal breaks, which are thermal bridges, you have to account for thermal breaks, ways in which you can make them less conductive so that their impact is less significant. And then, of course, we can't just put insulation on the exterior of the building and call it a day because it's going to get damaged by other environmental factors. So we put typically a shell on the outside of the building. And that could be something like on the Catawba College, where it's collegiate Gothic, we're putting brick. It looks very beautiful. Other buildings might put some kind of cladding system, like a rain screen. It's some kind of metal siding or thinner concrete panel that could be used that protects the insulation, those more softer internal layers. And then there's a little bit of a gap between them so that the moisture that gets beyond that exterior layer, that shell, can dry out to the ground as the insulation gets a little wet and then dries out over time.
Yeah, and that's another important point that again Joe made during his keynote. Wet is okay as long as it's followed by periods of dry, right? So, a lot of people tend to get the idea of building enclosure, building envelope confused. We don't want it to not breathe. We want it to respire, if you will. Explain that a little bit.
Yeah, so we use, there's just best practices, but sometimes you're looking at a wall enclosure and you're saying, this isn't really following those best practices. How's it going to perform? So my team inherently uses a lot of building performance analysis tools to help us evaluate those conditions. So one of those tools is something called Wolfie Pro. It lets us look at a wall assembly and say, over the next 5, 10 years, how's this going to perform, accounting for rain and wind and drying and wetting periods. And you'll see the moisture content fluctuate seasonally. And that's important because you want to see it fluctuate seasonally, but you don't want to see it go up over time. Because while a lot of wall assemblies might be able to dry out, water content over time can build up to mold growth and degradation of the materials. You may have seen some historic buildings where the bricks are falling off the building. It's because moisture is getting trapped behind the brick, freezing and pushing the bricks out over time. And so we got to be careful thinking about the long-term performance of those enclosures and those systems and accounting for multiple scenarios of how's it going to wet, how's it going to dry, and whether or not we're trapping moisture in layers we don't want to see it being trapped.
Yeah, and this is sort of where weather and climate and science come together too, right? Where I live in Charlotte, North Carolina, versus where I play more in the high country. The high country where we met at App State, that's actually a temperate rainforest. And the interesting thing about temperate rainforests is that you've got 4 seasons. So you've got a period of freezing, followed by a period of thawing, followed by a period of warming, followed by a period of cooling. Plus, you've got all of the upper atmospheric conditions associated with rain, moisture, snow, wind. So, those models must be super helpful when you've got a complex scenario associated with like a temperate rainforest versus just an arid environment, right?
They are, and we look at many scenarios, and often scenarios that we don't even expect in the real world, just to know that if that happens, we are still in a comfortably low risk scenario, right? We just talked about at the beginning of this call. There's events occurring now that are much more frequent than when we projected. 100-year events are happening much more frequently now, and so in that situation, if it gets significantly wet in a wall assembly, can it dry out over time? So sometimes we'll take our model, and if, let's say, it's a concrete wall, we'll actually double or triple the moisture content in that wall just to make sure it can dry out over time, that we're not trapping the moisture that, inherently in concrete. As you're letting it set and cure, it's very wet and it needs to dry out over many. We want to see those drying conditions over a long period of time and make sure that we're not trapping it between any barriers. Now, sometimes we want a barrier in the right location, but we want to make sure that we're not then trapping moisture somewhere else that might cause things like interior mold on the inside of the gypsum board, and you don't know it until you take the wall off. Like, you need to do some of these analyses to help us look at different scenarios. And there's this really fun experience I've had where typically running energy models and other things is a very solo experience, right? It's someone working at a computer like a nerd. I had this one experience where we were working on a historic building in Arlington, Virginia, and it was very historic, but it had 12 to 24 inches of brick. It was a barracks for the Fort Myers Fort Myers camp. Excuse me, the Fort Myers base in Arlington, Virginia, and it had this significant amount of concrete and really bricks that were 12 to 14 inches thick. That ultimately we said, well, we need to improve this thermal performance, so we're going to add insulation. But what type of insulation should we add, and how are we going to do these barriers? I had three very senior architects standing around my desk saying, well, what if I change this vapor barrier to this? And what if I change the insulation from open cell to closed cell spray foam, and each of the different configurations of possible walls, ultimately really getting to this great consensus that we all felt very confident in being the most resilient and reliable of those wall assemblies.
Yeah, that's what's got me super excited, Justin. Is look, I've turned into a tech nerd in the last 5 or 6 years, and I've been paying attention to things like physics informed neural nets and being able to add new data and change climatology associated with models and then render them and run these really beyond just this parametric design, volumetric design, but moving into
Hmm.
physics informed neural net where we can really create inferences and predictive analytics like raising HO2 levels in the troposphere and creating supersaturation events where you've got 18 inches of rain that falls in 2 hours. Sound familiar? Like
Yeah,
these things that are happening more frequently that we're seeing in IRL, in real life, we can run URL because we have the models now.
yeah,
So it's almost like business at the speed of trust now. Like, do we trust
yeah.
models? And that becomes the question is, do we have validated and verified data? Do we have systems that are not hallucinating? And how is this intelligent automation going to be used and applied to construction science as we move forward? So I love the work that construction science is doing, and it's happening in food science as well because we're seeing total degradation and total loss of crop, and that's all coming from weather, which is starting to smell like climate change. People want to believe in climate change, the deniers can deny, but I'm looking at ecologically sustainable and potentially regenerative systems thinking as a solution. So let's talk about that for a second. I'm hot on drawdown materials these days. Carbon sequestration, embedded carbon, it's a huge deal right now because a lot of what we need to do to reverse some of these effects is to capture and sequester carbon. And I'm a full believer in soil being the number one way to fix that. But
Mm.
I think the built environment can start to create some drawdown opportunities with materials, and also even just in something as simple as site selection or location. Let's talk about that a little bit. Let's talk about going, how can we get back to drawdown? How can we get back to carbon sequestration if we still have to build?
Yeah, so I think the industry is getting more intelligent in this regard every year. So there's kind of a lot of business as usual in the AEC, architecture, engineering, construction industry that creates a lot of risk aversion. So when you say, hey, I want to change our concrete mix to add in sequestration or slag or fly ash, there's an inherent, whoa, this is different. It's going to change my cure times. It's going to, where am I getting this from? There's always that kind of knee-jerk reaction and say, let's talk it through. Structural engineer, oh yeah, well we've done that up for 5 projects already. Okay, structural engineer is on board. Contractor, oh yeah, well we actually did it on recent skyscraper. Let me go talk to my colleague and there's success there. And then we're reaching out to the local concrete suppliers and saying, hey, what resources do you have to pull in fly ash and slag from other waste streams? So looking at it and saying, we could take waste from other industries, the production of steel, and use it as a input to our concrete construction process for the building is really great. But sometimes we don't have the supply chains in place. But just asking and putting out those RFPs, working on a project right now in Houston, and we've actually, even before started any construction or hired any concrete supplier, we put out a letter saying we intend to make this building significantly carbon reduced, lower global warming potential. We want, I think we're going all the way up to 50% fly ash in some of the various pieces of concrete, depending upon whether it's structural or otherwise. And we are letting the market know we want this demand. We want this supply. There's a demand for it. We want this supply in place to help this building offset its global warming potential and reduce its environmental impact. And that's just on the material of the structure. On the interior side, there's so much to do there. There's not a lot of people realize this, but over the life of the building, carpet is the number 3 largest environmental impact factor of the materials of a building, outside of the walls and the structure. You'd say, wait, why carpet? Because carpets replace so much. If it's a commercial building, every new tenant wants new carpet. They have their favorite color. So we're trying to really look at not only the environmental impacts of the carpet, but also accounting for the longevity of it. Is this a carpet that's going to be in here for 5 years, or is it a client that's going to say, you know what, I'm going to be owning this building for the next 30 years. I want to put in a long-term life cycle carpet, something that's going to last me 15, 20, 30 years if it's maybe a harder floor, so that they can reduce their environmental impact. Yes, day one, bigger environmental impact. Over the life, 30 years, it's less. So I know one of the big players in this field is Interface. Interface is a material manufacturer predominantly in carpet. They have an entire buyback program. They will take their carpet at the end of life, take it and turn it into recycled carpet, and you can buy recycled carpet from them. It's something like 98% recycled, and their biggest challenge is the glue. They can't find out how to recycle glue, which makes sense, but all the fibers that under the mat, it's all getting into a recycled buyback program, which is creating a cyclical chain for them, but not other manufacturers are finding that opportunity to recapture their carpet and turn it into something new. So they're really leapfrogging the industry in that regards.
Yeah, I got to shout out a friend of mine at Tarkett, Jonathan Stanley is doing a great job with that on the education side. If you're not familiar with their program, take a look at it. He would love to connect with you. He's in Greenville, South Carolina, doing an awesome event this week with Rex Miller down at PMC. So I'm sure Jonathan, when he hears this, will want to reach out to you. Resilient flooring is huge. I come from really our focus at Orion Growth at the early stages was tenant improvement and upfit. So we were working heavily with FF and trying to be responsible specifiers, knowing that churn was 5, 7, 10 years because it follows that same economic cycle of of leasing or depreciation. So ironic that the word depreciate would be the word that we would use, but it's not necessarily at end of life. So what happens after? We were always a big fan of trying to think through resilient design as it relates to turnover and churn in traditional office space. That's what got us into adaptive reuse, which is what got us out of traditional office space and into housing, because we like things like indoor air quality and we like things like living comfortably, and we like to understand what it's like to co-live without VOCs. So let's talk. We talked about sustainable materials a little bit there. Let's go to methods. Are you seeing or have you seen an increase in awareness for industrialized construction, offsite construction? Any of those, sort of progressive methods that sort of starts to take the assembly line and factories into play?
Yeah, so more of our clients are asking about in, requests for proposals, requests for qualifications. They're one of the questions that we're seeing pop up is, what experience do you have with prefabrication or offsite fabrication? How would we utilize it on our project? I think one of the challenges is that our industry hasn't inherently used a lot of that in the design of some building types or some regions. And I think there's a lot of education our industry still needs to have around that because regardless of whether it's been done previously, there are a lot of examples of it being done successfully. And so there's a lot better opportunity to be leveraging it more on projects, whether it's, there's a res hall that we did for Pace University where we did the entire unit as a big, you know, box that would basically come into place and be dropped right there, and we just connect the utilities and then put a cladding on the outside of the building, or just opportunities to do outside enclosures that I think we're just not tapping into enough of yet.
Yeah, I agree. There were a lot of really smart people in that at that conference, at the energy conference, from the IC industry, specifically because we have a lot of infrastructure for these factories in place in the southeast already, and we have a lot of areas that are rural and in need of economic redevelopment. The Appalachian Regional Commission, for example, running from Pennsylvania all the way down to southern Tennessee. Some of the work of Andrew McCoy up at Myers Lawson School of Construction at Virginia Tech and his work with the Virginia Housing Authority. As I mentioned already, Rob Leonard, who's a lecturer there at Virginia Tech, was there, and Adam Cohen, who was big in building enclosures back in the day, plus Rob Howard, who's a Howard Building Science that is a lecturer at App State. So, the IC world, industrialized construction world, seems to be focused on creating more efficiency around centralizing supply chain and reducing some of the human capital and human energy that's associated with all of these builds. One of the warning signs that they keep sending off in all of their lectures is that we've got a reduction in skilled labor and
Mm,
a lot of folks not entering the trades. And that gap needs to be picked up somehow, right? So whether it's roboticized, robotic process automation, or industrialized construction in the form of assembly lines, somehow we have to address that stuff.
yeah. Yeah, I think there's a massive opportunity that's not being tapped into yet. And some of it's regional and just what's available. But some of it's just understanding what are the various applications it works best in and how could you plan it from the get-go of the project, right? If you're designing a building, what's your module? What's your repeatable unit that can be industrialized? And designing around that, I think, is the key because it needs to start at the very, very, very beginning of design and then follow through all the way through.
Yeah, so volumetric design and metadata that follows spec books is something that the contract furniture industry is really good at. They've been doing this for a long time. So, and being that I come sort of from the commercial side of tenant improvements and office upfits, I can sort of see these parallels between the contract furniture world in central US and what's happening in industrialized construction, the need for a dealer distribution system and specifications and spec tools and spec books, building information modeling and the metadata associated with creating standards around these so that they're not
Hmm.
disparate models like they are right now in CET files with commercial contract furniture. Is there a future in that? Is that something that we think we will start to move towards as we continue to work on the supply demand curve of construction?
Absolutely. I mean, if a product doesn't have a Revit family, sometimes it doesn't get into a product or project. When we're looking at enclosure systems, curtain walls, window wall, those types of panels, it really, really helps us to have really rich BIM data to be able to put it into our project and say, okay, how does this start fitting into my digital Lego set in there inside of Revit? And so understanding those qualities, reaching out to those manufacturers. So I think there's a tremendous opportunity to say, okay, well, sure, I'm looking at a window wall, but what if my entire enclosure is a prefabricated enclosure system? How would I pull that information in? What details do I start incorporating, and how does it hang on the slab or the structural elements of the building? Those types of details are really important. But then we also just need the basic education of how does this system work? How does it plug into the existing design process. And, we're not going to be able to change everything all at once, but could we just start by saying, okay, we're going to make all of the exterior enclosure prefab, or most of it, maybe 90%. How would that integrate with the structural elements of the building?
Yeah, and so much of that comes with education and visualization tools. I've gone
Yeah.
down this path a little bit too with, Unreal and rendering imaging. Recently, Gaussian splats, moving away from LiDAR and photogrammetry more towards spatial and computer vision.
Mm.
And when you can see it and you can pick it apart and sort of look at ground penetrating radar even and look at things like what we're doing with soil structure in the ag space, looking at an entire system as a tree rather than
Mm.
looking at it as a mechanized system like an engine and how you tune something up. It really does sort of create this whole new experience around the built environment. So, have you had a chance to see what like Bentley Systems have been doing with cesium, or any of the new Gaussian splats or NERFs, any of that new sort of technology?
Yeah, so we've actually just started a partnership with Dassault Systems to start working on more intelligent and integrated digital twins to really try and say, okay, instead of it just being a Revit model over here and our energy model over there and a mechanical model over there, what if it's one model that holds all of that data? You can visualize it, you can click on an element and say, this is the exact parameters of that screw in the assembly of the wall. You can pull it all apart, and it's all in a really integrated tree structure that lets you understand each of those pieces, send them out to fabrication manufacturers, say, hey, I need 10,000 of these screws. Okay, let's start spitting them out. Really trying to get into an industrialized workflow. I think the challenges that the industry had, came from AutoCAD. Everything was 2D. Then they moved to Revit. Everything was 3D. That was a big change. Now we're saying, okay, forget the 3D. The 3D is important, but we need all the data that's part of that. And that is where we're needing to do a lot of education, because inherently architects are not data driven. But someone like myself is very data driven. I say, I want all that data because I can do better analytics off of it. And I can make more intelligent outcomes and insights to our clients to say, when you account for these thermal bridges, it reduces your, it improves your insulation by an R3. So it's important to invest in those thermal breaks. Those types of detailed elements need to be more inherently integrated into all of our modeling seamlessly. So I think a lot of it's education and opportunity to understand, okay, we've been doing it the same way for a long time, but the opportunity is there, and it's worth the risk of changing the way in which we're working.
Yeah, absolutely. And in tech parlance, that's persistence and interoperability in the model. Right now, there's a turnover of some form that comes with binders and zip files in a library, usually online somewhere. But there's no actual contextual model. Whereas from the operating side of things, looking at optimizing an opco, we're going to want to know warranties. We're going to want to know where FF&E sits. We're going to want to know specifications around fabrics and finishes. We're going to want to know VOCs, let alone leases. Smart leases are going to push through here when leases expire. The actual activity that happens inside of the building is also
Mhm.
going to need to be persistent and interoperable. So as we move towards the future, these systems of turnover will need to be more persistent so that we can then operate the model in real life and virtually at the same time.
Yep. We see a tremendous opportunity there. We're doing a lot of research in the digital twin space to try and understand what needs to go into the models so that they can use them for future what if scenarios or workforce training or other types of scenarios. Say, hey, my building's deviating from the expected performance that we're seeing in our models. Why is it deviating? Okay, well, this valve over here isn't seemingly open the same way it is in the model, and yet the temperatures are way different. Or you're looking at a future energy saving scenario and you're saying, hey, how much is it worth it to replace all the windows in my building? Well, you could say, okay, well, it's going to cost this amount of money. I think it might pay back. Well, take your model, update all the windows, see what the cost savings are, calculate that in terms of payback year over year, and quantify your payback of changing out all the windows is 10 years. Is that the right amount of investment for you or not? So we're looking at these opportunities to say, not only fault detection but also future scenarios, what if modeling to, and we see an opportunity to integrate AI and saying, well, now you don't need a building scientist to run your new model. You could tell it, hey, you already have a model, what if I changed my chiller to a new system? I'd be changing the coefficient of performance from 2.86 if you're doing like a maglev chiller or something really fancy. What type of savings would I expect to see on my building? And it can, go in and say, okay, change the chiller performance curve, change the coefficient of performance, rerun my model, and tell me what's the difference between them, and allowing someone to be kind of interfacing with their own building in a very interactive.
Yeah, these are the reasons why you said that so well. These are the reasons why I personally have killed the word sustainability from my language because I
Mm,
don't believe in sustainability. I think that's the minimum viable product is
sure.
sustainability. I think that, obviously in AECO, we have to have economic viability first. The whole point of what we're doing, it plays in with economics, whether it's, economic resilience or whether it's economic incentives or whether it just makes good sense. Then from
Hmm.
there, we can start to talk about environmental. And again, not sustainability, but viability, minimum viable. And then from there, you go into ecologically conscious, right? It's like awake versus aware versus conscious. And when you get to that sort of thinking in construction and in modeling, you really do start to pull on some new strings of like, what are we trying to do? So
Hmm.
let's get back to your project at Catawba because I think it's so interesting and I'm super excited to be close to it. And I want to meet Lee and the rest of the team when you guys turn this thing over because it is the first of its kind. But like, what are you trying to do here? Like
Yeah.
beyond just build a dorm, what are you doing?
Yeah. So Lee is such a great champion for sustainability, resiliency. He has speaking to interface. He really internalized a lot of their mission, and they have a whole documentary called Factory as Forest, and it's focused on how do we make our supply chains fully cyclical, fully regenerative. And so he's looking at his campus of Catawba College as the sustainability director there to say, how do we make campus as forest? How do we make a fully regenerative campus process? So they're in the process of trialing many different certification processes. They're doing a living building challenge for for the renovation of their academic commons called the smokestack. And on the new res hall, they said, we're going to do passive house. And it's great to have a client commit to doing passive house. Many clients out there are saying, we want to design to it. We want to make sure we have those principles. But the rigor that goes into the certification and getting it third party reviewed and having all those checks brings so much more rigor to that process. So from the very get go of the project, we heard this project will be Passive House United States US certified. So we said, great, we're coming day one with all of our bells and whistles. So we really actively try to do energy modeling even before winning the project to say what types of insulation are we to need in the wall? How high performing will the roof need to be? What's the glazing? Triple pane window, our U value less than zero point 0.2. Those types of parameters helped us work with our construction partners, Balfour Beatty, to say, hey, you're costing the project, you're putting a bid on it, we're trying to pursue it. You need to account for triple pane windows, R through walls, RC roof. Yes, we need that much, we need 6 inches of insulation on our outside envelope because we had to bring that rigor to it. So really, we were able to bring the rigor as Lee Ball set that same rigor for the project. What's also so beneficial is that as a campus, they are very holistically looking at the 13th university in the country to be carbon neutral and the first in North Carolina. So they're fully offsetting all of their carbon. And one of the big ways in which they're reducing their operations is they're installing multiple geothermal wells. They already have one on their campus. They're installing a very, very, very large one for our new res hall and the new academic commons that is then also allowing us to tap right into it. So day one, we're connecting this building to geothermal, which is then allowing us to be incredibly energy efficient on the heating and cooling side, like I mentioned, but also in the domestic hot water. We're putting in heat pump domestic hot water systems that are significantly reducing the amount of energy used for heating hot water in the building. A heat pump is about 3 times more efficient than the most efficient boiler. So we're able to produce the same amount of hot water at 3 times less energy, which is so significant in a dormitory or res hall scenario where students love to take hot, warm showers. So ultimately, we're really trying to put a building on this campus that has the lowest possible environmental footprint that impacts Catawba College overall mission of being carbon neutral.
Yeah, man, that's awesome. And one of the things that project and leads forward thinking at Catawba College benefit from is that sort of blank canvas thinking, right? Whereas you're not necessarily having to support calcified and legacy systems, especially through things like state contract procurement and specification. So there's a divide there, no? Where we have access to that sort of commitment at a Catawba College, where at, say, a public education opportunity that has traditional procurement through tax base, we may not have that same opportunity. So throwing good money after bad, I guess, is what they say, as we transition from
Sure.
legacy calcified systems into new thinking and regenerative systems. So how can we start to shift some of this thinking? Do we take the data? Do we fast forward 10 years? We've got a high performance campus. We've got monitor, record, and validation data. We're starting to report that out. We've built a 100-year building. It's working. Do we? I don't want to wait that long. Like, we need to get like sort of in action here. Urgency is a big thing. I'm not a patient guy.
Yeah.
So how do we do that? How do we get this better access to commitment in public universities as well as private colleges?
I think a lot of it does resolve around the data and the ways in which we're looking at long-term decisions. As a public entity, they are receiving taxpayer dollars in some way, and they need to know that their investment is a good investment. Now, some of the challenges that they struggle with, like we said, availability of expertise. Can they get someone in here to operate the newest and greatest complex system that's going to save them 50% energy on their new building day one? Maybe not, because it's a big maintenance and operational challenge. At the same point, they have a lot of legacy systems, a central steam plant that is challenging. Another one of our clients, Carleton College out in Minnesota, was looking at a very similar challenge. They had a steam plant. It was reaching the end of its life. They had a lot of steam pipes in their around their campus that were over 100 years old. They need to be fully replaced. They said, we're having trouble finding steam operators because they're high pressure. They need 24/7 oversight. You need someone in a steam plant 24 hours a day. So it's hard to find those type of steam operators today. And they looked at the cost of fully replacing their steam plant versus a geothermal transition. And they said, we're going to do it. We're going to jump headfirst into geothermal transition. And they transitioned their entire campus all in one big sweep because they looked at the long-term considerations of patching their steam plant forward, getting those massive leaks repaired, finding an operator, all those challenges, long-term costs of that versus an investment today. Now, not every campus has that opportunity, right? Some people are really challenged to say, we just spent, $60 million to keep our steam plant going. It's going to take us 120 to even get to geothermal. We don't have that money. We need to keep going today. And I think that that's a unique challenge that many universities and other institutes are struggling across, but I think we just need to bring data that's really trying to look at that holistic long-term projections of you make this decision today, what is that doing? So a lot of our clients are doing like utility master plans. They're looking at their entire campus and saying, well, we use steam and it supplies all these buildings. Well, those buildings need to transition from high temperature hot water to low temperature. Steam's going through that building at 180 plus degrees. If we're going to transition to geothermal, it needs to be 130, 140 degrees. So we need to replace all the cooling or the heating coils in the building so that they can continue to provide the same amount of heating needed to keep the space comfortable in larger coils with lower temperature in it. So there's a big transition you have to think about very holistically, but you have to bring all of the data together and have a lot of conversations, frankly, with the campus to understand what are their maintenance challenges. Are they able to maintain a system like this? How would they struggle to maintain their existing systems? What are the operational deferred maintenance costs of some of those things that need to be addressed first before they can even look at transitions and other things? So it's a really big ongoing effort that I think a lot of universities are trying to look at holistically in relation to their climate commitments.
Yeah, there's a field of study that I've been sort of down the rabbit hole of called ecological economics. If you're aware of that, if you're not, it's fascinating. And I think that there's a role for a PM or an FM somewhere inside of a project while it's in design development or even schematic to be an owner's rep, but take on the perspective of sort of this optimized operations company, OpCo FM perspective. Because really what ends up happening in our proverbial silos in our industry is that we cut a ribbon and we retire that project.
Yep.
For you at Page, that means going back to another project and feeding that next dragon, right? And then it's off to someone else for property management or facilities management, whether that's insourced or outsourced. And that becomes part of the problem. Again, we're cutting that interoperability and that persistence out of the system by using siloed approaches. So, have you seen any unique perspectives or unique ways of creating IPD for this newly found FMPM that's kind of an owner's rep that just sits and listens to the project and maybe raises their hand enough to say, we can step change this into something a little bit better rather than taking that whole step?
Yeah, great question. So we're in the process of trying to create more operational contracts with our clients where we say, hey, yeah, we designed the building, but we're also going to be retained for the next couple of years to make sure this building's operating the way we designed it. That you can call us up and say, hey, my controls guy totally messed up all of our set points. Tell me, just walk me through how this system is supposed to perform. What are the set points? Why are they balancing this way? How did you design it? How is it supposed to operate? And there's so many great examples of how operational commissioning plays such a big role in the real world performance of your building. There's so many times where we'll run a bunch of energy studies. Our client will call us up and say, my building's just not working. It's uncomfortable. The energy's really high. What's going on? We find out that the commissioning just didn't happen the way it was supposed to, that they never balanced the systems appropriately. And we come back and we say, this building's not working as we designed it. Let's work together to make sure we can recalibrate that. And that's the problem. That's the, hey, I had a problem. What's going on? We want to be more proactive and try and be partners with our clients and our partners to say, how can we remain as a resource to you to make sure these buildings are operating? And it's a definitely a change in the industry because like you said, it's, hey, it's done, let's move on. And it's more of a, wait, why do you want to stay here? Like, why do you want to babysit the building? But we have so much to learn from the project itself. And hey, we designed it this way. The operators are really struggling to keep the building running this way. Another interesting example is low flow toilets. We know that they're industry standard at this point for LEED, but when we were talking to a few maintenance people recently, there's some really big hurdles that they need to go through to keep those urinals flushing and other toilets operating. They have to dump in and clean it like weekly, basically, in relation to other toilets. It's this educational loop that we need to really improve between how's the building operating and how are we designing it. And I think that we're looking for more opportunities there as we progress forward, especially with clients that are more engaged. I mean, Lee Ball at Catawba College has said multiple times he really wants us to use this building, the new residence hall, as an educational platform for others in the region to understand how can they apply Passive House on their projects. How is it successful? What is the energy performance of the project? What are the educational opportunities? Articles, multiple things just to make sure that other people understand the opportunity that's present to them.
Yeah, building science requires building performance, and building performance requires us to monitor, record, and validate the data. And it's like looking at something like Boeing or Northrop Grumman, them not looking at the data associated with their high performance. Like they just don't do that. You don't build something and then not understand how it's performing. And that's a recursive model. The idea of just building something, getting a contract for a short period of time, completing what you were asked to do, cutting a ribbon and walking away, it's never felt right in the industry. And I've been at it for 25 years. Walking away from a project never felt right. And it's not the way I don't think that it is intended to be in the future. So I
Mm.
applaud you guys with that commitment to operations, because rolling up your sleeves and getting involved in the design, development, and delivery, you should also be tied to the performance at the end. And that only comes through, being able to iterate and being able to understand how that building is performing. We're not going to get it right all the time, but we're going to get it right. My favorite word is righter. We're going to get it righter than we did, because, perfection, we don't want to let perfection get in the way of good enough either, because that
Yeah.
just becomes another cost center. So let's transition a little bit. That's Justin, the scientist. That's Justin, the guy from Page. That's Justin, the passive design guy. Talk to me about Justin, the guy. Like, you got family. Like, what's your story? Where'd you go to school? Where'd you grow up?
Yeah, so I grew up in Eastern Pennsylvania, about 45 minutes to an hour outside of Philadelphia. Spent a couple years living in New Jersey, and then I went back to Pennsylvania to go to Penn State, where I graduated from Penn State with an energy engineering degree. I thought I was going to be the next greatest scientist to make a solar panel that would save the world and get us off of fossil fuel, but I realized about, three-fourths of my way through my college career that I probably should have been a material scientist if I wanted to do that. Looking at all the different materials and how they layer together. And luckily, I had a really great advisor that said, I'm not really seeing you as a detail oriented material scientist guy. I see you as more of a systems thinker. Come do an energy modeling senior research project with me on low income housing. So I did a low income housing senior research project. I studied the effect of shading and heritage trees in reducing energy performance or energy consumption on buildings. Use the deciduous nature of a tree. Can it help us modulate the solar heat gain at the right times and reduce it at other times of the year? I loved energy modeling so much. I said, you know what? I need to learn about buildings because I did engineering before. So I went and did a PhD at Rensselaer Polytechnic Institute in building energy modeling and other building sciences. So I did a year in New York City and then 4 years in upstate Albany, in upstate New York in Albany at Rensselaer Polytechnic Institute. And then I also spent a year at SOM in Chicago in their building sciences group, focusing on how to make sustainable skyscrapers. After I graduated with my PhD, I reached out to an individual named Teresa Rainey, who actually taught me energy modeling the first year of my PhD. Her and one of her colleagues, when she was at SOM, I said, hey, I don't know if you remember me, but I did a whole PhD focused on energy modeling. I was modeling cutting edge building systems, dynamic building envelopes, energy capture building envelopes, really, really cutting edge systems at the Center for Architecture, Science, and Ecology at RPI. And how do we represent them digitally so that we can better evaluate what if scenarios? What if you put this on a building in Phoenix? How much energy is it going to offset? Counting for the fact that it's changing your daylight performance, it's generating simultaneous electricity and hot water, those types of things. I figure out all the ways in which energy models shouldn't be used. Now I know the ways in which they should be used to help us inform design. So I came to Washington, D.C., working for Page to really evaluate and help our institutional clients, mostly in the academic, science and technology, and government sectors, where people are really owning and operating their own buildings, to say, when we make a smart decision today, it has these paybacks. Really work from the fundamental belief that when people have data, they'll make smarter decisions. But in the absence of data, they're very risk adverse and they'll make kind of business as usual decisions. So I'm constantly trying to bring data to every dialogue with the client saying, hey, if you make this decision, it's better for daylight. You'll have lower life cycle costs. You'll have better wellness and productivity in your environment because people are more engaged and they're happier. One of the ways in which we post occupancy evaluate our buildings is we often do surveys with students, and one of the number one features that they always highlight in the surveys is daylight performance, daylight quality in a space is one of the key factors they look for in a building that they spend a lot of time in, which is really, really important to us. So outside of that, I had a very incredible girlfriend who's now my wife, who stuck with me through the entire PhD. And we now have three beautiful daughters, a 6-year-old and twins that are 3. So I got my hands full at home too.
Nice. That's awesome. So, yeah, I love the idea of information into intelligence, kind of is where we're going. I think, we're past the age of information. There's a ton of noise out there, but then understanding and validating the validity or the even the veracity of the data that we're using and turning that into intelligent design is awesome. So your story is very similar to a lot of folks that I know, in that you went to city centers and learned about energy from buildings that are massively invasive to the environment. Any biophilic design and energy modeling around nature?
Yeah. You know, Biophilic design is an area that doesn't get enough modeling, but some of the most recent or some of the most interesting research I've read about it is they did a daylight study where they put people in an environment and they asked them to rate their daylight quality, and they put them in different scenarios. I think it was they put them in a test chamber at Lawrence Berkeley National Lab. They have a whole test bed that's like an office, and they can do a whole bunch of scenarios to it. And one of the things that came out of it that was most interesting is that the quality of the daylight through trees, the deciduous lighting of a tree canopy, was rated by far the highest daylight preference. not striations from a shading device or darker to reduce glare or brighter to really maximize the daylight. Deciduous light coming through a tree was by far the most beneficial light. It had the lowest glare quality, it had the greatest productivity focus, it had the greatest pleasure. And I think we all just inherently know that walking through a tree, being connected, or walking through a forest on a hike, being connected to nature, we all feel those properties. Another thing that was interesting that I heard recently from psychologist was that while we know a forest bathing is beneficial and it's something that's becoming more common practice to help improve mental health, sitting by water is even more beneficial. Just sitting next to naturally moving water has positive benefits. So there's a tremendous opportunity to say, how do we integrate more of these natural elements into our buildings in a way that feels natural, not just, oh, hey, look, there's a green wall, I can go over there and pet it. Ways in which you look at a plant and you're like, oh, that's a real plant in my building. That's not just a fake plastic plant that's collecting dust. That feels more natural in our built environment. Modeling it, though, is something we need to work on in our industry.
Yeah, we do. We do. I mean, obviously, we have to start to think about ourselves as part of the system rather than
Yeah.
control of the system. That's part of that orientation or observation around good design. Air, water, wind, and soil, or air, water, soil, and sun, I should say. When you look at that, so Shinrin Yoku, as you just mentioned, is forest bathing. There is a natural essential oil that comes from trees called phytoncides, and those phytoncides get on our skin, and our skin, the permeability of our skin is really important. So we not only feel better because we walked through nature, but we actually received something at 86 degrees. Those trees respire the highest level of phytoncides this time of year. So walking through a forest intentionally, listening, feeling, smelling, taking our shoes off, those are things that are real. Grounding, getting
Mhm.
your hand in soil, nematodes and microbiomes, that absorbs into your skin. So there's a reason that we actually feel better working in fertile soil and gardening. There's an element of that that is healing, and it's not just a hobby, it's reconnecting back to the earth. And the less bioengineered and the more natural that soil is, the more we stand to gain from it. So I love the biophilic design, the orientation and perspective of why it's important. And that's where ecological economics comes in too. It's taking that high value natural resource, running it through the economy, and recognizing that what we're left with is low value thermal resource at the end,
Mhm.
and how important it is to sort of think about that. The textured lighting thing makes total sense. I'd never heard that before, but it makes total sense that someone would feel the most secure or comfortable or optimized through textured lighting because they're actually receiving sun through that process of photosynthesis.
Yeah.
So the
I think
they receive
in
is
the
actually even more refined.
Yeah. And one of the ways in which we are bringing more data in that aspect is circadian lighting, right? It's such a, we all think about it, and maybe it's becoming even more common practice because more research is coming out about your circadian rhythm and how cell phones and indoor environments are really setting us out of cycle with our natural circadian cycles. And so there's a real opportunity, and I think that's going to be the next forefront is we're doing daylight analysis on so many of our projects now. What is the version of our buildings that are circadian responsive, right? That's really making sure the building occupants are getting all those natural light, all that natural light to their photoreceptors so that it wakes them up and gives them the right chemical response in their brain in response to those things and can keep them, you know, in the right cycles and healthy.
Yeah, and that's sort of where my work has transitioned from the future of work to the future of living, is that this wellness concept that we're talking about right now is so unstudied and under delivered,
Mm,
under deployed, but yet we're working more and living more from home. So the simple systems, mechanized systems like ERVs, right? Like there should, I don't know, I think an ERV should be on every house. Why? Because the natural exchange of air from outside to inside seems to make sense for me.
yeah,
Because indoor air quality is a thing. We kind of went through COVID. Not necessarily the purification of it, but at least the exchange between the two airstreams. And as we live inside and produce newer and newer buildings, we're producing more and more VOCs. We're
yeah,
producing an indoor air quality that's far below par with being outside. But my point is, you know, again, we'll go back through climate change. We've got forest fires, we've got CO2 in the troposphere, We've got other greenhouse gases that are changing our atmosphere, which means our regular air quality, our outdoor air quality is suffering.
Yep.
So how important is it that building science start to think about filtration, and creating better interior systems that protect us from toxins and things that are in the
Yeah, yeah, absolutely. So I think one of the most pervasive outcome in our design of buildings from COVID is a much greater focus on filtration. There is more fan energy that's needed to push air through a tighter filter, but we're seeing MERV 13 or higher filters on almost every one of our projects now because it's not just good practice. It's better for air quality. It's better for the indoor environment. Yeah, you do need to change your filter out more, but we're often putting things like pre-filters in a MERV 8 before a MERV 13 to take out those big particles before it gets stuck, and those tiny particles get stuck in the MERV 13. And so it's really acknowledging that there's a tremendous role that our mechanical ventilation systems play in creating those indoor air qualities and keeping the air changes at the right level so that we balance energy but also air quality and breathing for occupants. A lot of our buildings are really prioritizing higher filtration levels, and some of our clients that are even more security based are putting in like specialized carbon filters that are massive, massive inputs to our air handling units, but they're important for security and other ongoing operations in certain events or chemical conditions. So there's a significant focus on that in the industry.
Yeah. Well, we could talk about this for days because I didn't even get to water filtration and
Yeah.
the dependency on things like municipal water supplies and power. We didn't do anything about resiliency, being off grid, or how that can help lower the load. But I do have to keep my listeners to my commitment to 1 hour, and we're getting dangerously close. So let me ask you, Justin, if you were to best identify with one of these three adjectives, what would it be? Would you consider yourself to be a maestro, a maverick, or a misfit in your industry?
Probably a maestro. I think so much of what we do as building scientists is change management. It's taking best practices and making them better. So it requires a certain amount of education, a certain amount of data, a certain amount of trust to get everyone on board and say we're going to make this conscious change to improve. So much of what we do is coordinating multiple stakeholders, bringing in new data, having conversations that may have not been had before to say, is this
Awesome. Well, thank you very much. Did I lose your voice? Are you there for me? I hope.
yeah,
Okay,
but I
there we
think I'm
go.
back now.
Perfect. So yes, trust as the knowledge worker turns into the wisdom worker, because I believe that's happening.
Yes.
And businesses are moving more from knowledge to wisdom at the speed of trust. We can only move
Yes.
forward with an industry as much as we trust it. Thank you for spending an hour with me, especially
Thanks,
while
Chris.
you're on vacation.
Yeah.
We're gonna have to do this again because there's so much we didn't talk about. So let's let this marinate and let's
Okay.
let your project at Catawba College get a little bit further along. Is there anywhere that people can reach out to you or
Yeah.
find you?
Yeah, my preferred is LinkedIn. I definitely interface and engage more on LinkedIn than anywhere else. So feel free to look me up on LinkedIn. We'll definitely be sharing a lot more about Catawba in the coming weeks and months as we begin to write more articles about it and share our experience. And then construction is just started last month. So we'll have a lot more to share as we go through construction and then post occupancy. We really want to engage with the building occupants and capture that data so that we can better understand, is the building performing the way we expected, and is it even more energy efficient than we projected it to be?
Yeah, well, awesome project. Keep me in the loop. Let me know. I'll come snoop around if I can. If you're in the area, let me know. I'll self-invite. I love walking projects,
Awesome.
especially at those monumental milestones that you'll make. So, Justin Schultz with Page, thank you for spending an hour with us, man. I really appreciate it.
Yeah, thanks for the invite, Chris. Good talking with you, and looking forward to our next conversation.
You bet.
Bye.